And this is Karen O'Brien with part 2 of a video series that is an addendum to this April 9th, 2024 ASDSO webinar that Jim O'Brien is giving. So I'm going to be talking about, in 2 videos, the project overview data resources that was discussed in video 1, and now we'll be moving on to mapping results and discussing these various mapping tools. So again, remember, from this project we ran multiple different types of breach scenarios, and now we're going to be talking about how I created the map data and what map tools that we have to get this data mapped. Okay, so I'm going to move this off screen so that I can track it as we go, and we will be starting with the tool called Rasterizor. So what I have here is a group of rasters called results. And the way that I built this was with a tool called Rasterizor. So we start with a hydrology run. That was the first run that we did that had mappable results. And this would be the final depth of that project, or of that map. Okay, so let's take a look at how we develop these maps. So this is a tool called Rasterizor. And what we do is we just point to the file we want to map. That would be hydrology, and this is the export folder, and inside here are the output files. So if I click open, the Rasterizor should pick the project coordinate system, so you shouldn't have to do anything about that, but definitely check it. And then we'll just call this hydrology. Actually, I need to remove this one. Sorry about that, real quick. There we go. Hydrology max depth, and this will be going to a folder called maps. So all the maps stay in the same folder, and then and the style will be set to depth. And you click run, and then I'm going to click cancel, and you see that, and I don't think we need to see that, so I'll just minimize that. And you see that this map looks significantly different than the final map, but for a couple of reasons. If you double click on this map, well, first of all, your maximum rainfall was 422 millimeters on every grid element. So that's definitely higher than, your tall. So you should get that on every grid element. But if you wanted to kind of see a little bit more variation in what was happening on the floodplain and the watershed, you could set the minimum to 0.5, and then you would be clipping out of range values. And then you could see that you could set this to any value you want and just limit or minimize your map. You can also, if you were to change this from mode from continuous to equal interval, you would also be able to come in here and add more classes, set the colors to what you want. So for example, if I do 6, I can set this to 1 meter, 3, 5, 10, and then of course anything over 10 would be that bright blue color. Click apply, and you have a little bit more variation on your map. Of course, the next project that we did was the boundary condition. So if I turn off the maximum depth, you'll see that my boundary condition map, actually it needs to be on the bottom. This is the hydrology final. Let's put this back on the bottom, but it's a little bit harder to see. Okay, this is the boundary final depth. There we go. I put the wrong one down there. And this is the hydrology final. And so you can see that if you run your hydrology map, the first time you run it, it's going to show you where you need to put your boundary. And that's what this blue polygon is here. I'll turn that off now. And that becomes our boundary. It's a normal depth outflow boundary. So your first run is hydrology, your second run is to set the boundary. And then you can, do whatever you want with your tailings dam maps as soon as these models are running. If you need to capture, like say for example, you were using that hydrology run to collect the rainfall volume that would be filling this this impounded tailings area, then you could put a floodplain cross-section on top of it and get a volume of the flow that would be flowing across that into your tailings area. So you could use your hydrology map to get that volume that you need to store here as that PMP volume. In addition to that, you can also use this maximum water surface map. So this was also brought in by Rasterizor, but except pointing, instead of pointing to depth, it was pointing to a file called maximum water surface elevation.out. Now, since I already mapped it, I won't bother to do it again, but it will show you that those files do have to have a specific format, the ones that you use on Rasterizor. And I'll show you the depth.out, and that's grid element, X coordinate, Y coordinate, and then this is the parameter you're mapping. So in this case, maximum depth, and let's go down here to that maximum water surface elevation. In this case, maximum water surface elevation. Now, if you need to know what these individual output files report on, you can look at that in the Data Input Manual Chapter 1. Now, once you have this, it doesn't really look like a water surface because it's just a full elevation. So anything that doesn't have water on it is actually ground elevation, okay? So, but we can do cool things with this. So let me grab, I need a grid elevation map. So let me grab one from MapCrafter real quick. That's a basic map, site characteristics. Let me turn this on, and I need to leave that open. Now I want to show you something called a profile tool. So I think for now I'm going to turn off the Flow 2D plots, and then I will bring in this tool right here called the terrain profile or the profile tool. And this is a very handy tool. You can grab a layer and add it. So we'll add the water surface layer, and then we'll add the ground layer, and then you can change the color of those two layers. So we'll put water surface to blue, and we'll put ground to black, and then we can, okay, we know there's water in this part of the watershed, so if we drag a button across here, you can see that this would be the maximum water surface elevation on your map. You can see a little bit more collecting here. Oops, I didn't mean to hit right click. I meant, and then if you right click in the map area, it'll reset, it'll turn your line off, and then you can do another one. So then we can do one across our tailings area and see that we have a bit of a water surface on our tailings area too. Alright, so that is the profile tool. Again, it's right here, and it's a plugin you need to add to QGIS. So is Rasterizor, a plugin you need to add to QGIS. The next item on my list is animation. So let's just collapse all these, and we'll go to the animation group, and I'll go ahead and turn that on, and then I'll turn off the other two groups. So now we have, let's close the profile tool. We're finished with it, and now we have a different tool that will take time-dependent data from your Flow 2D results and will plot it on your QGIS map. So before you do anything, you have to set up your run. So if you use the control panel window and you go down here to the bottom of the control panel, this needs to be set to 1, and this needs to be set to 0. I would say for tailings dam, lower is better because things happen really quickly in tailings dam failure, and if you don't set this low enough, you may miss the part of the map that you need to see. If you need to adjust the start of when you start collecting this data or the end of when you start collecting this data, you can use the time interval. So sometimes I have to fill a channel or fill something, and that may take like 10 hours or something. So I could put my start time at 10 and then my end time at, this one ends at 24 hours. That would be your end time. So that would be how you use that time interval. But I don't typically use this on these short runs, only 4-hour runs, so I don't typically use it. So if you're not going to use it, be sure to uncheck it. And then you'll click save, and you will export and run again. I do not run an animation on every simulation because they do slow the model down and they take a lot more time to run those simulations. So I don't use them on every simulation. But once you have that data loaded, it writes an output file called timdep.out, and you can use this tool, which is the data source manager, and you can import the mesh. So all you have to do is point this to your project. So my project that has that animation data was the tailings dam tool, and here's the animation run. And I just put that, and I just select depth.out, click open, and then click add. And of course I'm not going to do it because it's already in here. That would just be a waste of time, because it does take time to load this data because it has a lot of data. And then once it's in here, it goes really fast, and everything plots really fast, and it's very responsive. But getting it loaded takes some time because it has to parse out that data and import it. So once you are on this layer, you'll want to click this guy. It's called Open the Layer Styling Panel. And when you first open that, it's going to try to share this space with your Flow2D panel, but that's not what you want, because both of these panels take up a lot of space. So instead, you're going to want to put your mouse like right in here and click and hold down the mouse, pick it up, drag it, and then as soon as the Flow2D panel turns blue, drop it. Now you have both of the panels docked in the same space, and it's a lot easier to see and use your panels. So the animation map comes with a lot of different kinds of data. You have bed elevation, this is time dependent depth, this is maximum depth, this is time dependent velocity vectors, and this is time dependent water level and maximum water level. So none of these time dependent surfaces have turned on yet because they haven't been initialized, and the time is probably set to 0. So to initialize this data, you see right here that it has a clock, and then you can come up here and find the clock button. Well, actually first let's close the Flow2D Grid Info tool, and then we open the clock button, and it will show you your clock. This is not going to look like this the first time you open it though. It's going to probably be empty. So you need to activate it. So you'll be on this level and you click activate, and that will show these extra features, and then you'll click this button right here, which will set the time step to the full range of the simulation. So in our case it's 4 hours. Okay, then you can start using this drag bar, or you can start advancing the animation data. And so this would be the depth and velocity and water surface elevation at the end of that interval. So like this one is at 1 hour and 54 minutes. This one is at 2 hours. This is the position of the water at 2 hours. So you can track the progress, the flood wave progression and extent throughout the project. And you also have the ability, so if you're on this, if you click on this group or this line item right here, and then you go to this styling tab, then you can put anything you want in here to style your map. So I've got 1, 5, 10. So if I wanted, I could do 3 and 5 and 10, and like maybe give me a little bit more color if I wanted to. But you have all the same tools on this styling panel that you have on these raster styling panels for these other rasters. Another thing that's cool about this is if you're mapping two meshes, you can compare, or you can copy the style from this layer. Sorry, I need the style. You can copy the style from this layer and paste it to the other result that you're comparing it to. So you can map multiple of these at the same time. There's a complementary plugin that goes along with the mesh tool, and it's called Crayfish. And the Crayfish tool is in the mesh drop-down menu, and you'll just click on, it's a plugin, you have to load it, but you'll click on the Crayfish tool and you can do a 1D, 2D, 3D plots. You can export animation, or you can export trace animation. Well, I'm not going to export the animation, that takes a bit of time, but I can show it to you. But the 2D plot is really helpful because what it gives you is, let's go ahead and, well, it doesn't matter where we set our time. Let's set this up. So you need to be on this as your active layer, so that means it's clicked and it's blue, right? Then you come down here and that becomes depth. You have to do this. You have to click all of these to load and trigger these to fill the data. This becomes time series. This becomes depth or velocity, whatever you want, and this becomes point. You don't have to worry about this one. Then you can put, as you put your cursor inside the area where there's flow, even if it's down here where the map hasn't reached yet, you get the plot of this water movement, sorry, this mud flow movement down to the edge of your map. And of course, if you go off it up here, you're no longer in the extent of the water. You can see that that is, and if you wanted to just put that on max, you'd be able to see that you could go up and get all of these, all of this data from this plot window. And that again is called the Crayfish 2D plot tool. And in addition to that, you also have this Crayfish export animation and export trace animation tools. Both of these work pretty good. So for general, you would set your output file when you want to save your project or save your video, and then you'd put your frame rate. You could limit the start and end time. In the layout, you could name your event. I'm not sure that this time one works, but you could try it. I don't know that you'd really want a legend, and I don't know if that works or not. And this would be a default layout, or you could do a custom layout and use your own layout. And then you would do something with your video. Oh, this is the location of this code. This FFmpeg is the what do you call this? It's like a video rendering code, and so it's what we use is to render all of this. It's going to take a screenshot of every slice of this video. It's going to take a screenshot of that, and then it's going to use this tool to convert it to a video. And it works really good, but I don't want to show you right now because it takes a long time. So that's Crayfish animation, and that's an AVI audio or an AVI video file, okay? That takes care of Crayfish, and that's basically all that Crayfish and the mesh tool does with Flow2D data, but you can use them for other data. So we'll turn that off, and now we're going to move to a tool called Flow2D MapCrafter that does kinds of mapping, but I'm going to remove this layer, and I'm going to go to the folder where that layer was saved, and I'm going to remove that entire path because we want to just rebuild it. So I believe that's in here, and yeah, there it is, and I'll just delete that. Then we'll rebuild it using this plugin right here called MapCrafter. So if you note that all of these are grayed out, but as soon as you load your map or load your project, it's going to activate the ones that you have access to. So I'm going to, let's just do this one. Click OK or click select folder, and it starts, and then it knows that this is a mudflow model, and it's going to give you all of these. But look, these ones are still grayed out because these are not mudflow models. Hazard maps is still active. Flow2D layouts is still active. Okay, mudflow maps. Let's see. So elevation, depth and velocities, depth times velocity, which is derived from, it's not really time dependent. This is just like the maximum data pair of depth times velocity that results in the maximum depth times velocity, okay? Because sometimes you may have a high velocity with a low depth, and sometimes you may have a high depth with zero velocity because the water's ponded. So it's going to give you the maximum of those pairs. Time to 1 foot or 2 foot. This is actually a little bit wrong because our model is the metric system, so that'll be time to 0.3 meters, or that you have to, it's just already set up in metric, but it still says 1 foot because the labels are a little off. Mud flow parameters would be the maximum sediment concentration. Structures, there's no levee in this one, so because it was a tailings dam tool, so no levee. And then hydraulics, specific energy, static pressure, impact force. So what we can do is just check them all. You might want to avoid doing that if it's a really large project, but this project, no problem. And we just click Create Maps. What it's going to do is it's going to build all of those maps in this location right here. And you can see, let me sort these by type or by details real quick. You can see that these are all of the files that it created. So 2 or 3 vector files, 2 vector files, and looks like there's a few things missing, but maybe you don't get it with that particular map. I thought there was some flood extents missing. And that might be, okay, this is the selected maps were created, added to map canvas. Just click OK, and it's going to close this out. And then what I'm going to do is I'm going to come over here and I'm going to collapse all. And then I'm going to maybe move this down here, and I'll just open it up like that. And then I'm going to do it again because I also want to do the hazard maps. And so we can, in this particular case, we can map the Australian method, the Swiss method, the US BOR method, and we can check the available maps and click Create Maps. And then I will, and these are the maps that I added, and I will again collapse it because we want to review these individually. So let's start with the mudflow maps. So first, as you map this, the only thing that's ever turned on is ground elevation, because we don't want this to start to refresh your screen, and that would be a really long refresh rate. So it's the only one that we turn on. And then if you looked at the basic maps, you would get, here's your maximum depth, maximum velocity, and that maximum depth is in the color brown because this is a mudflow model. But you have well, let's just use this one because it's already loaded, because we had to load it when we were doing our animation. But you have all the control of this file. Okay, so you can control the color, you can control how many levels, you have control over it. So you put it to whatever you want, and you can save those styles and keep them safe, and so that you can use them again and again. But we use these colors. Maximum velocities, we do greens for our velocities. The maximum water surface elevation is just like the other raster, except it's colored with those elevation colors. Final depth, final velocity, and now we have some velocity vectors. Now the style of the velocity vectors can be a little annoying because they have an outline in black. So I can just set the stroke width to 0. See, that turns it to no stroke. And then I can decouple the width from the height ratio. So this can be like 2 millimeters wide or less. Let's try 1.5 or 1. That's 1 millimeter wide. And then this height is a function of the velocity. See, field type. So it's a function of the velocity. So we can edit that. And if it's a little bit too long, you can say that it is a function of the velocity times 0.5 or divided by 5, divided by 2. Either of those work. And then you click OK, and that would minimize and reduce the overall length of your velocity vectors. You might find that you need to do the exact opposite for the final velocity vectors. So for example, if I copy the styles from, I'm going to copy all styles from the velocity vector max, and I'm going to paste it to, let's see, we'll go right click, styles, paste all styles to the velocity vectors final. But instead of using, and then I'm going to click, I guess I don't have to click apply because I already did it. I'm going to turn those on and then turn those off. And our velocities are much lower, and there's a lot fewer of them that are visible. So instead of dividing them by 2, I'm going to come into my velocity tool and I'm going to edit that, and I'm going to multiply them by 2. So that will make those a little bit easier to see. And so the way that velocities work with FLO 2D is that as your velocities get lower, that means that you have mud flow cessation. So if I have velocities like, say, in this area right here, and probably in this area right here, that are 0 or near 0, and possibly some in this area up here, that as those velocities become 0, that means that this flow has stopped, and that final depth in that area will be the mud flow, where the mud flow ceases to flow. That'll be your mud flow deposition, okay? And you can see that it's kind of happening all over the place. Good mud flow deposition. And this mud flow project was only like 30% concentration mud flow. So if you set that to something of a higher concentration, you would see a lot more deeper cessation of mud flow along these paths. So that's how you do mapping, and that's how Flow 2D mud flow mapping works. Let's see. Now, we already discussed the maximum water elevation. Let's go to, well, derived is just depth times velocity, so it's just a hazard for mapping hazard. It's one of the things that we use to map hazard. Time would be, this would be time to 1 foot and, or sorry, 0.3 meters. And this is the time that is defined on the map. So these are always the same scale. So you may want to set this scale to something that's more appropriate. But less than 6 seconds is that bright red color. Well, actually, this is not very, this is probably more like these two colors are too close together would be my guess there. And so you can modify those colors to make them look better. Let's turn off derived. And then this would be the, I think, the maximum sediment concentration. And that would be going from 0 to 0.499. This is the tailings dam tool. So I believe in the, in one of the mud flow models, we start at 0.3% concentration, and then we work our way up. And then in the tailings dam tool, we start at 0.5 and work our way up. So this is the tailings dam tool. That's why the concentrations are between 0 and 0.5. Now you could also run your rainfall on top of that, and then your maximum concentration would be adjusted accordingly. So I will turn that off. Hydraulics would be impact force is the only one that I'm really using, and this would be impact force. It's like a linear force, so what happens is you multiply it times the length of something that's in the grid element that it's assigned to, and that would be the impact on that, on the side of that feature. Okay, so that's impact force. And that is it for the mud flow maps. Then we have the hazard maps. So in Brazil, they use this Australian rainfall runoff hazard mapping system, and it has a set of colors that represent hazard 1 through 6. And if you go back into the tailings dam tool and you put your cursor on this, it tells you the levels for H1 to H6. And then if you wanted to, I mean, the map is fine, but if you wanted to use your ID tool, you could ID to get what variable that would be. Sorry. Which one were we looking at? Hang on. Let's try that again. Yeah, there we go. And that's 1 and that's 6. Okay, so not really super duper helpful, but again, that's the ID tool. And we also have the Swiss method, which is really more for mountain runoff, but you can have different kinds of either a debris flooding or regular water flooding, and then you can get the hazard levels from that. Now, if your Swiss hazard levels are not these colors, that's perfectly fine. You can swap out the colors with any color you want. I'm not going to show it to you on the Swiss map. I'm going to show that to you on the, I think if you look in one of the US BOR manuals, they have these mapped and they have different colors for these different categories, and I'd have to like dig up that. I think I have a PowerPoint of it somewhere. I'd have to dig that up, but the colors are different. So easy peasy, right? There's only 3 hazard levels for this US BOR for these different categories, and you can just easily change the color. So this hazard level 1, we could just put that to yellow, and hazard level 2, orange, and hazard level 3 can be red, and you can click apply, and that would sort that out for you. Of course, you could use whatever color you want. Now, if you copy that color, if you copy that style, you can paste it to all these other guys just like that. So then you can see now that my colors are U.S. Bureau of Reclamation colors rather than, well, I mean, I'm not really sure if that's what the USBOR colors are. Those are our FLO 2D colors from our other mapping program. So the BOR might have different colors in their document, in their manual, and you could just set it to those colors. Oops. So I think we're done with that. And so that's your hazard mapping. And let's see, then that is MapCrafter. Then we're going to do floodplain cross sections. So we have some floodplain cross sections set up in our model, and you can see them a little better if you plot them like this. Now, if you're on the new plugin, it's called version 1.0, and it's a lot shorter than this plugin, but you'll be able to load your project path where you ran your model, and you'll be able to click these individual lines and plot these cross sections. But with plugin 1.15, we do it a little bit differently. So first we set the project path to the folder that we want to review. And I think the one in here that has data, that has, like, I think I tried it on this one and that one didn't have data. Well, let's just do this. Let's look in them and see really quickly which ones have data. So I'm looking for a file called highcross.out, and it looks like I have 4 of them. And of course I can't see where they're located because you can't expand that, so maybe I can click on it. That one is Mudflow, Tailings Dam Aspen. No, that one's empty. Yeah, 0 bytes. That one was empty. This one is two-phase. This one is the dam and levee. That's just water. And this one is, oh, that's a different project. Okay, so let's grab, I think we want this one. It is export Mudflow. Okay, so let's put this to Mudflow and select the folder and click OK. And now we are going to, now look, these have an ID associated with them, okay? And you can either review them like this. Nope, wrong one, sorry. Floodplain cross section. You can review them like this. This is number 1, and you hit the center button, and this is number 1. And then if you go down, that's 1, 2, 3, etc. Or you can turn their ID on. If I double click this, I can set the label on the label tab. I can set the label to FID. And let's turn that to bright green. And let's make it 12. And now you can see that these will be, this is how we look at which floodplain cross-section we're looking at. So now I want to run the program called Hydrog. And once you run Hydrog, it's going to go to that output folder and pick up the highcross.out file, which is right here. And you got 1, and that would be the hydrograph crossing number 1, 2, 3, and then 4 and 5. And so that would give you an idea of the hydrograph crossing that, and of course that hydrograph would change. You know, are we doing water? Do we have like 50% mud? Do we have 50% mud with one set of mud flow parameters? You know, that's going to change as you change your projects, and you know, typically run like maybe 10 different models to represent different types of concentrations, different mud flow parameters, different failure rates. We test all kinds of different things when we set these models up, just to get a feel for how things are moving and how things are working. So in addition to those cross sections, in the highcross.out file also contains the volumes. So if you are to open the Mudflow and go to that export, you can just get highcross.out, and let me open that up. I don't want to get it too big, I guess. So you get the total volume of the water passing that line, and I don't know why I cannot read numbers that don't have commas in them when they get that big. So that would be the total volume in cubic meters, and this would be the total discharge across that line for this particular cross section. So you can get the volume and the max discharge across the line. So, and then you can also get concentration by volume. So this particular run maxed at 0.3 but you of course want to check that with different concentration by volumes in your mud flow model. I'm going to close that and not save that data. And that is the end of floodplain cross sections. So now let's see. Close that. No, I don't need to close it. Let's just go down to the very last item, which is back in the MapCrafter tool. There's one final tool called Flow 2D Layouts. And so what we can do here, this doesn't have anything to do with this path, I don't think, unless you, no, because when you select it, you're going to be able to save it somewhere else. Okay, so this goes to, let's call this is the Tailings Dam tool, Aspen Mine 4-hour Tailings Dam tool Aspen Mine 4-hour test, or 4-hour results. And the map description would be like a description of the project, any kind of project description. This could be your company description, whatever you want to put here. So let's just say the description goes here. And then your layer extent is set to the grid, and then you're going to select one of these map layouts. You'll either do one of these types of portrait or one of these types of landscapes, and my favorite is this one. And then click Open Selected Layout. So maybe it is going to put it right there, or save it right there. And it will open the layout and then load the map. And so whatever you have checked on as like viewing map, it's going to plot that. So let's minimize it, and we're going to cancel this because we're finished with it. Let's see what else we have open here. Let's cancel Rasterizor 2. We're finished with Rasterizor 2. And let's start turning on some of our results back on. So let's go, whoops, we can grab our hazard map, and we can grab our, whoops, not that one, maximum, final, and maybe one of our velocity vectors, and our ground elevation. And then it's also already checked on will be these guys. And let's turn off the schema layer. Now, when you go back to your template, you should be able to refresh that, and those maps should load. And so once you refresh that, these will be the maps that are exported with your PDF. And so you can export these maps to a PDF or an SVG. I don't know, I've never tried it with an SVG. Oh, it looks like there's not. Okay, well it says don't use SVG export, but let's try it anyway because I don't know what it's going to do. So let's put this into PDF map export, and let's just try that. Let's just see what it does. So let's see, export map layers as groups. Sure, why not? Always export as vectors. I really don't know if that's important. Crop to content. Nah, that's not important. Disable tired raster layers. Yeah, I don't think any of our raster layers are tiled anyway, so we'll just click save. And let's see, if that starts taking too long, I will pause the video until it's complete. Oh, it looks like it's done. Let's see what it did. I don't even know if I can open an SVG without some sort of viewer. Let's see, that went here, and let's see. Oh yeah, that's okay. It can't read it. Let's try. I don't want to open it with, I only have one project that I know of that can read an SVG file, but I bet it's vectorized and layered. So that's SVG. I've never tried to do that before, but let's try to export as the PDF image. Let's see what that does. PNG, we'll grab that one too. Generate a world file. And let's do one more PDF. Okay. Now this one is, I think, I don't know what's going to happen here, but I'm kind of hoping to get this as like, I'm not exactly sure how you get it, but you have to do something to get it to be able to turn layers on and off. And I'm thinking it might be like needing this. But if you do this, it adds all the layers of the project, which is really annoying. So let's turn that off for now and not do that. Click Save. Okay, now let's go in here, and first off, we'll try this guy. I think that's just going to be an image. Yeah, that's just an image. There's no layering and things like that that we can do with it. Pretty nice looking image though. Oh, and by the way, you can replace this logo with your images. You can replace this description with your description. You just click on it and go to properties and put your description here. And you can put a scale in here. No, is it a scale? No, a legend in here too. So you can do all that stuff in this editor. And let's try this one last file, which is going to open in Adobe Acrobat. And I'm not sure that we have layers, and I don't know why, because we should. And so I'm not going to deal with it for now, but you should be able to export that with layers, and then you can check those layers on and off really easily. But I'm not going to try to figure it out right now, because I think maybe it could be something to do with the version of Acrobat that I'm using. I have no idea. Anyway, so that's how you use the layout tool, and that is basically it for the different types of Flow 2D maps that you can create for your projects, and the different types of time-dependent data and animation data that you can use to help you identify hazard zones and evacuation routes. And you can identify all those things. You can point sample any of those maps with important points. You can do profiles anywhere across this of any of those spots, and you can link those profiles back to the map. So it's just really excellent tool. So I appreciate your attendance. I'm going to shut the video down now, and I hope you get something out of this video.